making a video. Probably not the best camera for this video, but it doesn't matter. Yeah, a couple of different subjects. Guess we'll do comments first on the last video, and then I want to play a bit of a FEYNMAN video, and then a little bit of a one on, I don't know, motion or something. So there was a comment by the Roboto guy. And it's not here anymore. I don't know where it went. It was somebody marked it as spam. I approved it, but it's not here. But anyway, his critique was something like atoms are different sizes, and that would mean that there'd be a difference in the vibration, the speed of the vibration, and so my vibration theory couldn't be correct. Blah blah blah. But that's really not the point. The point is that the proportion of the time that the thing would be at the certain positions would still be the same. So no matter how big the atom was, and no matter how slowly or fast it was vibrating, the proportion of time that it would spend in any one position in that oscillation would be the same. So, I mean, I probably should do the oscillation video first, just since I'm on that subject, but I really want one. It's just too confusing. So the idea is that no matter how fast the vibration is, the truth is that it has to accelerate to the midpoint, decelerate to the end point, reaccelerate to the midpoint, decelerate to the end point again. So I mean, it's the same. The proportions would still be identical. So it doesn't matter how big the atoms are, and that's why it doesn't matter what the material is that you make the slits out of. It won't change the slits because it doesn't matter how fast the atoms are vibrating. It just matters that they're vibrating, and they always vibrate the same way with a certain amount in terms of time. They're always in the same positions, the same amount of, not the same explicit amount of time, the same proportion of time is spent in the different locations. You'll either understand that or you won't. So anyway, this asshole, these are assholes. I'm sorry, these guys are just rude and they're wrong. So yeah, if you're going to post a comment, you really should be right. If you're going to act like an obnoxious, arrogant motherfucker, then you should be saying something absolutely correct, not something absolutely incorrect. Okay. So Petrosadimopoulos. This experiment is completely different from the two-slit one. No, it isn't. In the lather, the slits are large. No, they aren't. The two-slit experiment has actually been done using an electron microscope, okay, with slits that I think were 70 nanometers wide. Very, very small slits. I mean, it's just a fact, fuckhead. The point is the slits can't be too big, okay, or you'll destroy the interference pattern. But there's no such thing as too small, almost. Photons are really, really small. Anyway, whereas here the one slit is of a size comparable to the wavelength of the light beam. Well, again, the wavelength of the length of the light beam is its length, okay, so it's not its width. And I'm arguing that the length is merely the frequency, which is the distance between repeating photons. That's what establishes frequency, and there really isn't any wavelength, because there's no wave. There's just a frequency of photons. And you're not refuting that with a single piece of evidence in this rude and obnoxious pontification of falsehood. And you're false. You're wrong. Wavelength of a light beam. A remark the lecturer makes that you seem to ignore. No, it's the same exact remark he makes in the two-slit experiment. Again, they're very narrow slits in the two-slit experiment. You're an idiot. You're wrong. You're rude. You're obnoxious. And you suck. Only then diffraction is the most apparent phenomenon. Well, again, that's not the argument made in the two-slit experiment. Even the experiment done with an electron microscope, there was an image shown of one slit covered, and there was no apparent diffraction pattern. So with one slit covered a 70 nanometer slit, there was no diffraction pattern. I'm just saying, this seems like a preposterous inconsistency. You can't have it both fucking ways, and one of you assholes ought to explain how you can have it both fucking ways. Only then diffraction is the most apparent phenomenon. Anyway, the lecture is some 15 parts long for a reason. The lecture is some 15 parts long for a reason. And what is the reason? I've watched the lectures. Okay, I haven't watched every one in this series, but I get the pattern. The pattern is he's going to do the same exact math over and over and over again. That's what he's basically going to do, which is his prerogative. He teaches the way he wants to teach. I think it's a little bit redundant, but that's just my opinion. It does the math to show that light is a wave. Well, you can't do math to show light is a wave, so that's nonsense. The math is a representation, a manipulation of variables. I'm not disputing the variables, except I'm saying that one of the variables, okay, is the movement of the matter, the influence of the matter, the electrons that the photons are interacting with. That's why the slits are there, so that the photons can interact with the matter of the slits. You people really just don't get it. It's not a wave. Space is not a medium. Photons are not waving through space. You're being silly. Anyway. It does the math to show that light is a wave as much as a duck is a duck. Well, that's really clever. You should have said a duck is a bird. But anyway, and I'll explain to you how this duck wave of light is not a wave, because it is not in a medium that has tension. There is no tension between photons. They cannot communicate any kind of wave dynamic. You have absolutely no material evidence of this phantom wave that the photon is riding on. You're just making all this crap up, and only 1/3 of physicists will agree with you on this Copenhagen interpretation anyway, because the other 2/3 have some other wacky theory. So I mean, sorry, you fail. It does everything a duck does. Well, whatever. It doesn't do everything a wave does, and that's the whole point, isn't it? That in most cases with photons, they do one thing, which is kinetically react with matter. That is, this much goes in and this much goes out, and the only thing that changes is the direction. The electron is changed in its direction, the photon is changed in its direction, and that's all that happens. And the only thing that's deceiving you is that you don't realize that ultraviolet light is 4 times, it's got 4 times as many photons in it, well, 2 times as many photons, as infrared light. So when ultraviolet light goes in, yes, it produces more photons, theoretically, because you're misunderstanding it and not realizing that it's about how many photons per second go in, not wavelength. Yeah. But the space that separates atoms is space. It's not a medium. I've made videos about this, so I guess I won't go any further on that. So anyway, so you're just absolutely wrong. It's not a completely different slit. It's exactly the same small little slit. The 2-slit experiment has been done microscopically, so you're just wrong. You're just wrong now. I hope you post a comment admitting you're completely wrong. You wasted my fucking time having to defend myself against a false accusation by an ignorant slut. Yeah, okay. So next. I think what we'll do, whoops, I had to find the right mouse here. Lots of stuff to work on here. Lots, busy. Lots of stuff going on. Quantum probability, this is it. So we're just going to play the end of this Feynman thing when he gets to these questions, because this is where he really says some shit that's just amazing. Electrons and light, well, I don't know if this is terribly interesting, but we'll play it anyway. If we can get it to play. Alright, we're going to have to reload it. It's okay. It won't take too long.
And I would like to...
There we go. Let's go out there.
I think it's just weird. The reason is that the answers from this are so simple. That is what's a little complicated you're not used to it. But mathematically, those forms and those curves are mathematically so simple, and the rules are so simple, it's hard to make any mechanism at all that can reproduce such simplicity. The Mayan thing was really fairly complicated. The numbers were peculiar. There's no explanation of them. This analogy, our numbers are not peculiar. They have an explanation.
Okay, well anyway, he's answering questions, but so he's talking about light refraction, and light, off the surface of glass was the subject of the lecture, essentially. He was using that, the Newton thing, I think. And explaining how it's this timing thing, like you do his little circle thing, like a clock, and then you make your vector, okay, for reflection off the surface, and then you make a vector for reflection off the bottom surface. You put them end to end, and then you do the line across the hypotenuse, and then you do a circle around the hypotenuse as a radius, and the area of the circle is the probability. So that's basically the mathematical relationship. So again, it's just variables in, okay, and he's using a formula, okay, to manipulate those variables. So it just depends on accurately defining the variables. And in the end of this, like I said, he concedes that he has shortcutted the math in the sense that he has misdescribed the actual phenomenon. And that's sort of elucidating, right? Because in this video, I think it was this video, no, in the videos from the 50s when he explained this same phenomenon, he would make arguments like, well, how does the photon know when it's on the surface to reflect 8%? How does it know how thick the glass is? So how does it already know how thick the glass is to be able to reflect the proper amount off the surface? And then he concedes in this video that it's really not about surfaces. It's about the entire layer of glass, and that these refractions off electrons are happening through the entire period of the glass's travel through the medium, and its probability of encountering an electron, and its probability of being reflected at that point. So it's really about the density of the refraction moments. So every material subject, this substance, has a likelihood in terms of its density of the material to refracting light. So transparent materials obviously have a low density to cause refraction, that like the photon will not often hit an electron in a way where it will be refracted, where in other materials it will hit an electron. Just, it can't get anywhere through the surface, barely get through the surface before hitting an electron that will cause reflection or absorption. Conversion. And it's always a conversion, right? It's either, even a reflection is a conversion. The electron is being absorbed and then readmitted, and in other cases the photon is absorbed and it's readmitted as a different form of energy, photons. It's readmitted at a different wavelength, and that different wavelength, whether it be radio or thermal, infrared, it'll release photons, but they'll be released at a different wavelength. So it's really reflecting. You just don't see the reflection, because it's not visible light anymore. So it goes in as visible light. It comes out as invisible light. But it's still light. It's still photons. And that's sort of really important. Physicists should say that. Anyway, let's play some more. Come on, mouse.
It's a different situation. One more thing about gravity, I would just remind you that we don't really have a good model, because what comes to why is it that there's a force inversely to the square of the distance? And what do you mean?
Yeah, a force inversely to the square of the distance, which is exactly the shadowing effect if you account for gravity as being photons. So the theory that he discounted, right? He was a critical player in the modern re-examination of this theory from the 1700s. He made a critical commentary on it, saying it's not possible that this could be an explanation because it would generate heat and that it would forestall momentum in the universe. You could never travel at any velocity in the universe because there would be drag. So the two elements that he said existed don't exist if you really take the theory seriously and you understand that at the atomic level there is no friction. Heat is a conversion of high energy photons into lower energy photons, that is the number of photons in the row, and that's all it is. Heat is not a consequence of the interaction. It's a consequence of the conversion of one grouping of photons into another kind of photons, in the sense that you send them out in a different packet. So they came in as 4, you send them out as 2 and 2. So they go in ultraviolet, they come out infrared. So a 4 goes in, 2 comes out. That seems more energetic, right? Because now you have 2 elements flying through the system. Where before you only had 1 element, which was 1 row of 4 photons. So the energy was in one direction, and now you have 2 elements leaving in 2 other directions. So it has the effect of what you might call causing more chaos, in the sense that there's more directional changes that will take place because of its existence. The fish will now swim in more patterns, but the fact is they're still swimming at exactly the same speed. There's still the same amount of energy. It's just the pattern has changed. And patterns are critical to maintaining or creating, to having velocity. You can't have velocity if you have too many patterns going on. The patterns have to slow down. They have to go away to gain velocity. But anyway, so that's it. But I don't want to get. That's another subject. So I want to stay focused on the fact that the gravitational theory is a kinetic. It does not require. Photons don't split in half. Photons are a single kernel of energy. All they do is exchange directional information. So that's why there's no heat created by gravity, because when the photons go through a body, a material substance, the gravitational photons, the gravitons, if you want to call them that, when that happens, what is taking place is the gravitons are flying out again in another direction. So that part is equal. What went in goes out. And the only thing that's changed internally is now my electrons have been altered, in the sense that their orbits have become eccentric in a specific direction. So now there's more internal directional change. So the only thing that's changed is that a mass of my photons have now been slightly altered in terms of their orbits, and that is creating what you can consider the acceleration, because they are eccentric and not changing their speed. So that's a whole other issue, but I don't want to get into that. So that's why there's no heat, and the reason why there's no problem with velocity, the fact that there's no drag in the universe when you're flying through these gravitons, that's another one of these kinetic arguments, that when you crash directly into pure kinetics, when 2 bodies that will not create friction fly into each other directly, there's a non-event. The past and the future are exactly the same, whether they hit each other or they don't hit each other. So effectively, a direct impact kinetically is a non-event. So therefore, that's why you can have acceleration and velocity in space without there being drag, is because it's entirely there's no exchange of energy. So there's no conversion. There's only changes in direction, and the direction can't be changed because it's a direct impact. You're hitting things directly, and the angular momentum remains exactly the same, because it's purely kinetic. What goes in essentially comes out. So yes, his lament that we don't have a good theory is partly his fault, because he destroyed a good theory by not recognizing that atoms are not sitting in a medium, that they exist in a kinetic environment where there is no energy conversion. Photons cannot convert into energy. They are energy. Okay.
Inversely is the square root of distance. That's mathematical. And Newton was the one who taught us that we can make progress if you stop arguing about that. He said, I make no hypotheses. I don't explain the gravity law. I tell you what the law is. That tells you how the things look, and you can predict where the stars are going to be, and that's the pattern. But I don't, at the moment, know. So he left open the question, just like you asked. Maybe tomorrow somebody will figure it out.
Well, that's the sad truth, right? Is that somebody figured it out 200 friggin' years ago, all right? And you just played a stupid game to discount a perfectly valid explanation that is incredibly lucid, that pretty much matches our experience with gravity and duplicates the math perfectly.
On your particular question, it's always possible that tomorrow somebody will figure it out, but it's going to be very difficult and very strange.
Well, like I said, it wasn't very difficult. It's not very strange. I thought of it, somebody thought of it 200 years ago, exactly the same, pretty much exactly the same theory. I'm just prepared to make the argument about the frictionless environment, and Lesage wasn't prepared to make that argument, and so his theory got crushed because he wasn't capable of explaining why there's no heat and why there's no friction or drag opposing acceleration in the universe. Now I can explain that, so I have the tool he didn't have, and that's the only difference. But yes, you did destroy it for pretty much a minuscule complaint that if you really did think about it like a physicist and actually think about atoms being in space and not being in a medium, you would realize that there is no friction, that photons are in fact energy, that they can't be converted into something else. They are energy.
Do you like the idea that our picture of the world has to be based on a calculation which involves probability?
Not really, if I get right down to it. I don't say I like it, I don't say I don't like it. I am very highly trained over the years to be a scientist, and it's a certain way I have to look at things. When I give a talk, I simplify it a little bit, I cheat a little bit to make it sound like I don't like it. What I mean is it's peculiar.
Yeah, well that's the thing though, you cheated a little too much. So that would be my critique. Yeah, you have to cheat because, yeah, you make comparisons, you make analogies. I mean, I'm making analogies to a pool balls on a frictionless table. And it's probably a pretty safe analogy, but it's analogy. It's not three-dimensional. It doesn't really explain it. Einstein cheated by talking about curved space as a fabric, which is another two-dimensional, and it's, besides being two-dimensional, it also depends on gravity, a notion of gravity, to even work, because you'd have to have gravity that pushed the thing down into the curve. So it's kind of a silly explanation of gravity in that it has gravity presupposed to exist above the fabric, so that there has to be something pushing the thing down into the fabric for his analogy to even work. And really, all we're really talking about is a convergence, where stuff goes into a sucking of pulling, and what it actually is a pushing. So we keep thinking of it as a pulling when it's actually a push. And the push is by reason of a photonic pressure that can be shadowed.
But I never think this is what I like, this is what I don't like. I think this is what it is, and this is what it isn't, okay? And whether I like it or I don't like it is really irrelevant. And believe it or not, I have extracted it out of my mind. I do not even ask myself whether I like it or I don't like it, which is complete irrelevance. It's kind of a
Okay, yeah, well again, yeah, it's really not though, okay? I mean, you know, intuition, I would argue, is useless in most cases. But when something just doesn't quite sound right, maybe that should be a little warning sound should go off in your head, and you should say, yeah, I don't think that's going to be able to do it. I don't think that's the skeleton key. It's got a funny shape, and I've never seen a key that shape. that kind of stuff. You have to kind of say sometimes, yeah, that's sort of evidence that there might be something wrong. Is the fact that you don't like it, that it just doesn't seem to fit the diagrams that you have running in your head. So if I say the word dog, and somebody's holding up the picture of duck, maybe I should take that seriously. That I've never seen a dog that looks like a duck.
When I'm lecturing, I shouldn't have said I don't like it. What I was trying to say is you probably don't like it. There's nothing I think we can do about it.
Yeah, see, again, so you see the futility in this argument? Like, see, I'm a really smart, see, I mean, there's a kind of arrogance there where, look, we're really smart. Einstein's really smart. I'm really smart. We're really cool. We built the bomb. If we can't figure it out, nobody can. I mean, that's what they're sort of saying. And I think it was just, I think they tripped on their own arrogance.
It might have been something else. I don't know how else to express it. It's not really personally a dislike.
Have you left out anything in this lecture which you need to add later?
It's very difficult, and I worked very hard on the lecture trying to use as my examples things that I didn't have to change later, the interpretation slightly. I couldn't get an elementary enough process that I didn't have. Later on, I have to make a little change.
But see, this is the thing. He says he worked hard on this lecture. This lecture is some 20 years after the other lecture, and it seems like he was trying to imply the same conclusions that aren't correct. That there is actually light reflecting all off the surfaces, and there is no light being reflected by the material itself, the density of the glass. And so in both lectures, he's making the argument as if this is the truth, when he's really just saying, look, we can do this really horrible math where I have to include an infinite number of electrons in this probability equation, or we can take this shortcut where if we just do the beginning and the ending, we can do the math that includes the center. And that was just, I mean, it cheated reality. It cheated the truth. And, he shouldn't really be proud of that as a well-done lecture. I mean, it's just ironic that it took a questioner to point out a fact that was just really quite, I mean, it really was an elephant of a fact. It's a big one.
You see, we talk and we see as though it's reflected at the surface. Actually, what's really happening, and a deeper understanding, which I should do later on in the lecture, I might forget, is that it's reflected, it affects electrons in here which re-emit light. Here, or here, or here, or here, or here, or here. And what really is the things that we have to add is not the arrow from here and the arrow from here, but a whole lot of little ones from all the distances from there to there. But believe it or not, you get the same answer.
Right, but the key point what I would make here is that if you explain it that way, then it's not so illogical to understand how the photon at the surface, quote unquote, knows how thick the glass is at the end, because what's happening actually is that the first part of the glass is reflecting just normally, and the deeper the glass goes, the more likely it is you're going to have refraction. So that's what it understands, and I mean that's a mechanism of the glass. And if you include into that my point that as you make the glass thicker and thicker, you'll change the alignment of the atoms inside the glass. So a key fact in how this happens with glass is the fact that glass has very well aligned atoms, but the fact is as you change the thickness, you change their ability to vibrate, and their alignment will change. So now the atoms will be, instead of one atom, one atom, one atom in a very straight linear line, electrostatically held at distance, with tension, it's a medium, what happens is the atoms don't fit anymore. So if I make this glass a little too small for the atoms to fit in there, it's like cookies in a container when there's too many or something. They'll start to go at different angles. And so now the atoms are not at the same position, and that's what's causing the extra refraction, is as if you make the glass smaller, you change the alignment. And once you take away an atom, so if 9 atoms fit here, and I make it a little narrower, and there's a point where I'll get to where exactly 8 atoms will fit in here. and then it'll go back to the same numbers when they're all in a perfect alignment. And then as I make it smaller, it'll go down to 7 atoms. So each time I change the thickness, I change the alignment of the atoms, and in doing that, I change the amount of light that will reflect as it travels from point A to point B. So anyway, that's my explanation of why it goes from 16% to 0% as the amount of light that's refracted by the glass. So you can have glass, depending on how thick it is, the thickness is key. You can have glass that has almost a 0, it reflects, mirrors almost 0% of the light coming in, and glass that will reflect up to 16% of the light that hits it, depending on how thick it is. And how the photons know is because the photons are traveling through a matrix that is not the same. The glass changes as the thickness changes. Yeah, I think I explained that well enough.
Okay? So what I really ought to do, and I would do if I were doing it correctly, would be to talk about the reflection from every interior part and adding arrows. But I would rather add just 2 arrows the first time than an infinity of them. So I cheated.
Yeah, so I cheated. And again, another important fact he did say right there, you know, in the previous sentence was, there is no reflected light. All the light is refracted in the sense that it is absorbed by an electron and then readmitted as a new photon, or as a photon now that has been absorbed and readmitted. And that's why there's often a color change in light when it's refracted. A color shift.
Didn't cheat a little bit. I got myself in a slight hole which you picked up. The actual reflection is from the material. The electrons in the material.
Right. So, I mean, this is, and I concede the point, yes. This is a fundamentally different description of the actual reality. So in his lecture, he's basically saying, look, light reflects off the surface, and then light reflects off the bottom surface. And he implied that that's how it works. Okay, that there's a top surface of reflection, and there's a bottom surface of reflection, and there's no other reflection taking place. And now he's conceding the point that no, the reflection is a combination of all the little reflections that take place through the entire material.
In the case of Newton's thing, it's because the electrons which are reflecting from the glass here and here are interrupted in their pattern, and when you add the arrows, it comes out to be, believe it or not, the same as if you just take the one from here and one from there. Perhaps just for those who can, I don't want to make it too hard, but just to give you a clue of the marvelous way it works. If you added tiny arrows to represent reflections from everywhere, instead of just talking about reflected from here to here, which is a good equivalent way. But if you took a whole lot of little baby arrows, each one a very, very tiny angle from the other, all the same length, which is the reflections from all these places, you see you generate a circle. And what I was using instead of the circle were the 2 arrows, which were the beginning arrow and the end arrow of the circle. And what you told me is I shouldn't talk about the reflection from the front surface and the reflection from the back surface. I should talk about the reflection all the stuff in between.
Yeah, so, and what this diagram is basically just describing, you know, so this is, how's a good way to point this out? This use of geometry to duplicate the mathematics, the proportions. And that's really what it's an argument about, is the proportions. So let's understand that as a photon travels through time, the atoms are also traveling through time. They're moving. So the 2 things are moving, and one of them, the photon, we kind of say, yes, it has one thing. It doesn't do anything, but it has a frequency, but it doesn't have any jiggle. But the atoms do jiggle. The atoms are distorted by the condition of the material, the thickness of it, and so there's a proportion that's created. So this circle basically sort of represents the idea that you would have 16 at the top, you would have 4, you would have 0 at the bottom. So it's a representation of the cycle that's really just the cycle of going from 8 atoms to 7 atoms to 6 atoms to 5 atoms to 4 atoms. So this circle sort of represents what you're doing in terms of changing the condition of the medium through which it's traveling, and it would be reflective of, you know, what position you're at, what is more likely the condition of the atom. So when the atom's in one position, it's more likely to encounter a photon, and when the electron's in a different position, it is less likely to encounter a photon. So yeah, that's a little. It's a little difficult to take this abstraction and make it coherent.
True. The net result of going around here is the same as going up here and back on that one. It even accounts for the minus sign. That is, the distance from here to here is what you get by putting onto this arrow this one backwards. Well, the distance is the same, see?
So it's about that triangle.
But this line is the same line.
And so you probably don't really need to create the circle, because all you really need is the proportion. All you need to do is say it's a percentage of a whole. So whether it's almost like the pi thing would be unnecessary, in the sense that whether it's the area of the circle, you know, a circle, or the square that a circle fits inside of, the two really don't make a difference, because it's identically proportional. It'll always be the same proportion of white space to circle space. So the proportion between the amount of space that is in the square but not in the circle and the amount of space that's in the circle is always the same proportion, no matter how big the circle is. So you really don't need the circle, but it just makes the vector thing work better. Talking about spinning.
Like it from the interior. But in the first lecture I thought I'd just get 2 arrows instead of an infinite number.
Does your picture...
Okay, that was the end. Anyway, so yeah, that was interesting. I'd seen these lectures, but I just hadn't remembered him. I sort of remember him doing the little arrow thing, but I didn't realize what he was actually saying when he was doing that was that this isn't about surfaces. It's about the condition of the glass, and as you change the thickness of the glass, you change the condition of the glass. Okay. He wasn't saying that, but the point is what he was saying was opening the door to that explanation. So again, my explanation is validated by this recontextualization of reflection on surfaces. Alright, so the other thing I wanted to get to, and I'm less certain how I want to play with this bit of video, is on harmonics. But it sort of goes back to the comment by the Roboto guy, and how
if a spring oscillates in a simple harmonic fashion, and we have such a spring here, Marcos, if you can do me a favor and get it up here, then I should be able to demonstrate that a uniform circular motion projected on the wall, we call shadow projection, should be able, thank you Marcos, should be able to have the same motion as my spring, provided, of course, that we vary.
Okay, so what's happening here is this: there's going to be a ball rotated in a circle and then a ball bouncing on a spring. And what's going to be illustrated is they both have the same exact movement. Now, the part not, and it's not terribly interesting as a statement here, I don't think, but I mean, I find it interesting just in the sense that it's a way of understanding frequency and understanding acceleration and understanding speed. So the trick with the ball is it's moving a consistent speed around its whole orbit, but it's moving a bigger distance, right? It's doing all this distance thing. So instead of going up and down, it's doing a huge amount of extra distance. And what the spring is actually doing is a huge amount of spatial speed difference. The spring unravels at a speed. There's high degrees of acceleration within the spring in terms of as it stretches out and reaches the end point, stops, and then accelerates again to the back to the point. So what I found valuable in this is that it illustrates the fact that if you do take the extension of the spring and realize that what it's actually doing is as it extends, it slows down, and then it speeds back up again, and that this is the conversion here is in distance. So distance is accounting for the rotation, and here speed is accounting for the frequency. So it's just because you can manipulate those two. And again, relevant to my argument, photons can't do a difference in speed, you know, and they obviously can't do a difference in distance. So they're rigidly obliged, okay, to travel a certain distance in a certain time period, and they cannot adjust to anything.
Carefully make the period of oscillation of the spring exactly the same as the time for this object to go around. We then shadow project it on there, and then I will even try to release this one, it's very difficult, at the same time that this one is here, and what you will see then, you will see the uniform.
Yeah, this guy, I mean, I like him, but he was way too much of a performer. I mean, he's always, you know, he swings on pendulums. He's always doing, like, circus tricks. It's just, you know, it's a little bit obnoxious.
Circular motion projected becomes a simple harmonic motion, and you'll see the spring simple harmonic.
Yeah, well, also understood in the spring is the fact that it's just the circle, and as you unravel the circle, which is the spring, you're really just making more circles. So in a sense, that circle has to move through space as it unravels. So when the circles are all compacted, they're not moving. There's no distance, there's no anything traveled. But as the spring unravels, you could almost visualize it as the circle, just like the thing spinning. It's really, as the unraveling happens, it's kind of like the unscrewing of the circle again. So even though it did travel distance, what it really did was turn the full cycle also. And that's, you know, part of why these two things are identical. It's just it's a different model of exactly the same mechanism.
And so we'll try to do that in shadow projection. We'll make it a little darker.
I mean, the same distance is being traveled again, so that's the irony, right? I'm saying there's a speed difference, but there certainly is. But the real point is that it's still the same distance being traveled. It's just being traveled in a spiral instead of being traveled in a circle.
And for that, I need some light here.
I mean, so what I'm saying is if you add up how many miles this thing goes, you know, how much distance it goes, it would be the same amount as the distance traveled by the uncoiling spring if you counted every time it moved another cycle in a direction, and you counted that as a circle. So the small, even though the spring is small, but it moves one Planck constant down, you have to count it as a rotation. So it's a rotation, a rotation, a rotation, a rotation. So it's a lot of little rotations that would add up to the same amount of distance as this ball is traveling. Pretty sure of that.
Here. Okay. And we took, oh, someone already took it up. So here you see the spring, and there you see this object, which is rotating in a circle, but you think it's a simple harmonic motion, and that's of course my objective. So now that is difficult. I will have to block you for a few seconds. I will try now to release this at the same time and also at the same amplitude. Boy, exactly next to each other, but you see they have the same periods, and they both represent.
Right, so you can sort of see that the spring, as it's unraveling pieces of it, it's going to be, there's much more speed in the unraveling, and then when it gets to the end point, it stops, and then it goes in the opposite direction. So it's just, the tension isn't even. The tension is, it has a different acceleration at different points in its period. So there's more acceleration in one part of it than there is in the other part of it. In the spring, the ball just reflects the end result. So this is the wave, this is the sine wave, but the sine wave is essentially being created by accelerations that are not even. So that's sort of my point. So anyway, I think that's enough for now, for today. Yeah. Yeah. This is getting clearer and clearer. I mean, I really should be able to provoke some sort of response from somebody, because this is too good. It really is. It just makes too much fucking sense. So, until next time.